manufacturing scales reach new heights, the Grade2XL project stands as a landmark of innovation and collaboration. The project aimed to revolutionize the production with 3D printing of large-scale multi-material structures using wire arc additive manufacturing, or WARM. The potential and implementation of WARM are demonstrated across all stages, starting with the properties and microstructure of functionally graded materials, through design topology optimization and the development of the printing process, to specialized equipment and inline inspections. The process culminates in qualification tests of 8 industrial demonstrators in Ghent, Belgium and Delft, Netherlands. Coupon tests have been performed.
WARM deposition of dissimilar materials is much more complex than the deposition of monomaterial blocks. We use high-resolution microscopy and other state-of-the-art characterization techniques to reveal the WARM microstructural evolution down to the nanoscale and correlate it with the process parameters and the properties at the macroscale.
Repair application of WARM enables a longer lifetime of essential equipment. Hot forging die demonstrator of Kuznia Jawor from Poland required high-temperature resistant material, especially towards the surface of the die. With WARM realized at Dutch company Ramlab in cooperation with the University of Wrocław, significant savings in repair time and enhanced material properties were achieved.
Within this project, we develop efficient multi-material topology optimization methods for additively manufactured structures under combined thermomechanical loading and implemented them into our in-house software. The developed methods consistently outperform other state-of-the-art ones. We also successfully employed the in-house software to optimize a large-scale mode for composite production at GKN. In 2023, our work was highlighted on the website of the Innovation Radar by the European Commission.
The components of the ship propulsion systems produced by Manny S company from Denmark must operate in seawater for 20 years. WARM allows combining low-cost and expensive specialized materials in the same build, resulting in a higher strength at the core and anti-corrosion properties at the surface. This opens up new degrees of freedom in propeller design and could lead to more efficient propellers.
To print highly performing demonstrators, Ramlab has developed a MaxQ system to ensure that each layer of the part is perfectly deposited. The core elements of MaxQ are the sensors and software that enable geometry control, interpass temperature control and real-time current and voltage monitoring.
Dutch company Valk Welding has developed a unique water-cooled torch design that reduces the temperature buildup during deposition. Combined with the cryogenic cooling system developed by Air Products, it helps to increase the productivity.
We applied the aforementioned developments to actual industry cases. By using WARM for repair, we are able to double the lifetime of metal parts while achieving less production failures and a significant reduction of the lead time. This was realized in dies and forming tools provided by Gorenje Orojarna from Slovenia. We have successfully designed and deposited novel hard-facing materials without defects. And the dies are being tested in a real production environment. Another key achievement of Grade2XL is the development of the flexible manufacturing system. It incorporates a cobot arm, a high-throughput welding source, the MaxQ system, including also non-destructive testing possibilities.
In Grade2XL, we have redesigned the holding ring for hydroelectric power plants provided by EDF in France as a tri-material part. The part printed at Naval Group has now an advantage of the improved corrosion resistance comparing with the conventional part. Another big step within the Grade2XL project is the inline inspection development by CEA in collaboration with Ramlab and Naval Group.
CEA has been working on different aspects within the project. The first one is the characterization and inspection of the demonstrators at their final stage with ultrasonic, eddy current and X-ray techniques to ensure their integrity. And the second axis is the monitoring during the deposition. Preliminary studies have been made at TU Delft with X-ray fluorescence and laser Doppler vibrometry systems. And we are now at Ramlab with the latest system directly connected to the WARM machine and the MaxQ system to realize tests on more complex geometries. Our objective is to be able, with the LDV system, to send information to the WAM machine when an event appears during the printing process to significantly enhance the safety and reliability of the production process.
Injection moulding die for automotive applications provided by shapers contains conformal cooling channels, a quite challenging feature. The new 3D printed part shows improvement on cycle times by 30% due to integration of conformal cooling channels. It is also more resistant to wear thanks to the added hard-facing material in contact area, which increased the lifetime of the part. DTU performed meticulous assessments to validate the environmental and economic impact of WAM versus conventional manufacturing methods. The results showed that multi-material WAM technology offers a multitude of advantages. For instance, in the case of Gorenja's forming die, the environmental impacts could reach up to 80% thanks to the use of hard-facing materials. The possibilities for innovation and sustainability are numerous. Qualification of these WAM-produced parts is a last important step before all these demonstrators can be used in production. We developed a qualification roadmap for WAM components and materials, leveraging the diverse application cases produced during this project. An external industrial advisory group comprising various companies and certification bodies was established to guide our efforts. Best practices for printing parts with WAM technology were identified and compiled from manufacturers' feedback to improve the development of printed parts for future applications.
The developments in Grade2XL have been disseminated to the public through webinars, workshops, participation in innovation events and market fairs all over Europe, courses, scientific conferences, and journal papers.
The Grade2XL project was managed by the Material Innovation Institute, M2I.
Materials Innovation Institute, M2I, coordinated Grade2XL project, creating efficient ecosystem for rapid industrial uptake of joint scientific breakthrough results. Multi-material WAM technology opens up a field of possibilities in both new construction and maintenance, and it offers new perspectives to production.
Grade2XL is funded by the EU Framework Programme for Research and Innovation. Visit grade2xl.eu for more information.